And on to the final question of the paper, which, as so often in higher level maths, is about vectors, or at least predominantly about vectors. Two distinct lines, L1 and L2, intersect at a point P. In addition to P, 4 distinct points are marked out on L1 and 3 distinct points on L2. A mathematician decides to join some of those 8 points to form polygons. Now I'm struggling to visualise that at the moment, so I'm going to draw a very quick diagram. It doesn't have to be amazing here. I have L2 and L1, and they meet at a point P, and then on L1 I have 4 other points marked out, and on L2 I have 3 other points marked out. Don't know where they are relative to P, but that helps me visualise the problem. Part A, Part 1, find how many sets of 4 points can be selected which can form the vertices of a quadrilateral. So I need to ask myself here, how can I form a quadrilateral? Quite clearly, joining these 4 points here will give me a quadrilateral. Equally, joining my extreme points gives me a quadrilateral, and there are lots of other possible combinations as well. But if I pick points all along the same line, then I don't get a quadrilateral. In fact, if I pick 3 points along the same line, I just get a triangle with a self-contained point. And if I pick P at any point, the most I can do is have 2 on one side, so that will give me 3 along a line, so I can't have P. So the first thing I'm going to write down is P cannot be part of this building. And then equally, I need 2 from L1 and 2 from L2. No other configuration works. As soon as I have 3 on L1 or 3 on L2, I'm just forming triangles that contain one of my points. So I then just need to work out how I can choose each of these things. So I choose 2 points from L1, so that's 4 in total, choose 2, and 2 from L2, that's 3 in total, choose 2, remembering that I can't use P. And then I'm choosing both points from L1 and from L2, so I use the product rule, I multiply them together. 4 choose 2 is 4 factorial over 2 factorial times 2 factorial. 3 choose 2 is 3 factorial over 2 factorial times 1 factorial. So 4 factorial is 4 times 3 times 2 times 1. Divided by 2 factorial would be 4 times 3. Divided by 2 factorial again would be 2 times 3, so that's 6. 3 factorial over 2 factorial is just 3. And then 1 factorial is just 1. So I have 6 times 3, which is 18 possible combinations. That's part 1. Part 2, I can use my same diagram, find how many sets of 3 points can be selected which can form the vertices of a triangle. So now I start to look. If I look first, can I use P? I absolutely can, in this situation, use P. And then, additionally, I can either have 1 on each line plus P, or 2 on one line and 1 on the other, or 2 on one line, but then not P. So the easiest way I'm going to approach this, really, is to work out all my possible ways of joining 3 points together, and then subtracting those that won't form triangles. So my possible ways of joining 3 points together, I've got 8 points in total, I'm choosing 3 of them, and then I need to subtract all the situations where along L2 I choose 3 points, so that's 4 choose 3, and along L1 I choose all 3 points, and that's 5 choose 3, because now I can count P as one of my points, and that lies on both lines. So 8 choose 3 is 8 factorial over 5 factorial, 3 factorial. 4 choose 3 is 4 factorial over 3 factorial, 1 factorial. And 5 choose 3 is 5 factorial over 3 factorial, 2 factorial. 5 factorial over 3 factorial is 5 times 4. Divided by 2 factorial is 5 times 2. So that's 10. 4 factorial over 3 factorial is just 4. And 1 factorial is just 1. So that's 4. 8 factorial over 5 factorial is 8 times 7 times 6, and 3 factorial is 6, so that's just 8 times 7, which is 56. So I have 56, subtract 4, subtract 10, that's 42 possible combinations. Then I'm given some more information. The line L1 has vector equation that, and L2 has vector equation that. The point P has coordinates 4, 6, 4, that's where they intersect. Verify that P is that point of intersection. So the word verify in the exam means I can really not be that rigorous and still get the marks here. I'm just going to substitute that point into each of my equations. 4, 6, 4 is equal to 1, 0, 1 plus lambda 1, 2, 1, which in turn should be equal to minus 102 plus mu 562. Presentation never really my strong point. So I have 1 plus lambda is equal to 4, so lambda equals 3. I can just check that. Lambda is 3, lambda is 3. And then equally mu, I have minus 1 plus 5 mu is equal to 4, so mu is equal to 1. And I can just check that. 6 mu is 6, yes. 2 plus 2 mu is 4, yes. And so I've verified, therefore, that 4, 6, 4 is a point is on both lines, and therefore a point of intersection. There you go, and that is enough for a verify. If it were show that, then I would have to solve these two pairs of equations, but I don't need to do that here. Then I'm told point A has those coordinates and lies on L1. I'm asked to write down the value of lambda corresponding to point A. Write down just means I can give the final answer, and that's what I will do. So I have 1 plus lambda is equal to 3, so lambda equals 2, and I'll just check in case I've screwed up in the exam. 2 times 2 is 4, 1 plus lambda is 3, and I'm sorted. I'm then given point B, lies on L2, it's got those coordinates, and I'm asked to write down PA and PB. I can do this in a number of ways. I could do it more formally, just by thinking about P and A, let's say, and some ephemeral origin off to the side. And so vector PA would be minus OP plus OA. But actually, it's probably easier just for me to think about this in terms of what's actually happening. So from P to A, I'm moving from P to A. So I'm asking myself, what do I need to do to P to get to A? So point P is 4, 6, 4. So to get from P to A, I need to subtract 1 from my X values. I need to subtract 2 from my Y value, and I need to subtract 1 from my Z value. And then PB, I do exactly the same thing. What do I need to do to P in order to get to B? So to get from 4 to minus 1, I need to subtract 5. To get to 0 from 6, I need to subtract 6. And to get from 2 from 4, I need to subtract 2. And there I have my vectors. Then I'm told let C be a point in L1 with coordinates 1, 0, 1, and D be the point in L2 with parameter mu equals minus 2. Find the area of quadrilateral CDBA. So the first thing I'm going to do to approach this is I'm going to want to draw a diagram. And in order to help me do that, I'm just going to collect all of my information in one place. I want to know the coordinates of each vertex. And I know they're actually given to me, but 3, 4, 3. It really helps me here to collect all of these individual terms. C is 1, 0, 1, and then D, I'm told mu is minus 2, so that's minus 1, minus 10, minus 11, and then that's minus 2 times 6, minus 12, and then 2 minus 4 is minus 2. So visualising this then in my diagram, if this is P, where P was 4, 6, 4, all 4 of my points, it's not really drawn sensibly, 2 lie on each line, so maybe we should write that down. A is on L1, B is on L2, C is on L1, D is on L2. So I have A and B. I'm choosing my less steep line to be L1 because its direction vector is less steep. It doesn't really matter here, it just helps me visualise. And then I have C and D, just looking at how far away those coordinates are from my point P. And so my area of this quadrilateral here then, I can't just do a half mod BD cross BA to get the area of a parallelogram, because this isn't a parallelogram. Instead, I'm going to split this into 2 triangles. Now there are loads of ways to do this, but I'm going to split my triangle down here, and so my area ABCD is going to be equal to a half mod and then CB cross CA. That gives me this area here, plus a half mod BC cross BD. BC cross BD, giving me half this area here. There are other ways to do this, as I say. As long as you're picking any two vectors that start from the same point and construct your triangle, and your triangles are mutually exclusive, then you add them together, you're absolutely fine. But now I need to write all of these things out. So I have half mod, and then CB. So that's, what do I need to do to C to get to B? So I have -2, I have 0, I have 1, cross CA, so I have 2, I have 4, I have 2, plus a half, and then mod again, and BC is 2, 0, -1, and BD is -10, -12, -4. I'm just going to move my working over a little so I can fit it on my page. So I have a half, mod, and then to do the cross product, you can just use the formula that's given in your formula book, but to be frank, I don't know it. I much prefer this way. So form a 3x3 matrix. Your first row is your unit vectors, your second row is the first vector, your third row is the second vector, and take the modulus of that, plus a half. And then I have, once again, I, j, k, 2, 0, -1, -10, -12, -4. Hopefully your working will be slightly neater than mine. So I take my cross product, so I'm going to get two vectors, because your cross product gives you a vector normal to the other two vectors, not relevant here. So firstly, I have -4i. Secondly, I have 2 minus -4, I have 6j. And thirdly, I have -8k. And then for my second one, exactly the same process. I have 0 minus 12, so -12i. I have 10 minus -8, so 18j, and then -24k. And so I have a half times the square root. 4 squared is 16, 6 squared is 36, 8 squared is 64, plus a half times the square root. 12 squared is 144. 18 squared, I'm going to do 20 times 18, which is 360, and then subtract 2 times 18, 36, to give me 324. And then 24 squared, I'm going to do 12 squared times 4 squared, 2 squared, so that's 144 times 4, which is 400, 576. Now add these together, I have a half times root, and then I have 116, plus a half times root, and then I have 468, so 968, so 1044. The question doesn't specify what form it wants me to give the area in, so I can leave it in my exact answer, because it's a non-calculator paper, just like that, which is a nice little 8 marks. And that whole question, therefore, is 20 marks sorted.